ATR FTIR spectroscopy. ATR FTIR spectroscopy is an analytical technique used to obtain the infrared spectrum of absorption of a sample. ATR, that is attenuated total reflectance, is a powerful sampling technique integrated into FTIR instrument that allows direct analysis of samples with minimal preparation. The IR beam reflects inside a high refractive index crystal and penetrates slightly into the sample via an evanescent wave. The sample absorbs IR radiation at its characteristic frequencies, which are then analyzed to identify chemical bonds. ATR is especially useful for analyzing solids, films, or biological coatings. It provides qualitative and semi-quantitative data about molecular structures by analyzing how they absorb IR radiation at specific wavelengths corresponding to the vibrational modes of chemical bonds. Every molecule has a unique IR fingerprint, making ATR FTIR ideal for material identification and functional group analysis. So, the principle of ATR FTIR: an IR beam enters an optically dense crystal, for example diamond or zinc selenide, at a specific angle, undergoing total internal reflection. At the point of reflection, an evanescent wave extends a few microns beyond the crystal into the sample. This wave interacts with the sample surface. If energy of the wave matches the vibrational frequency of a chemical bond, that energy is absorbed. The detector records the attenuated signal and a spectrum is generated via Fourier transform representing transmittance versus wave number. About the instrumentation, the IR source for the ATR FTIR is typically a glow bar, that is silicon carbide, which emits a broad IR spectrum. The interferometer, that is a Michelson design that modulates the IR light by creating constructive and destructive interferences patterns. ATR crystal, a high reflective index material like diamond or zinc selenide that facilitates internal reflection. In order to hold the sample, the uniform pressure and contact between the sample and the crystal are applied. The detector used in ATR FTIR, DTGS or MCT detectors that sense the IR beam after interaction. So that the software converts interferogram into a readable spectrum via Fourier transform. The working of ATR FTIR: initially the sample is placed directly on the ATR crystal. When IR beam is internally reflected, the evanescent wave interacts with the first few micron of the sample. This is ideal for surface level analysis, as different bonds absorb IR radiation at different frequencies. The resulting spectrum shows peaks at characteristic wave numbers, enabling functional group identification. For example, a peak around 1720 centimeter inverse typically indicates a carbonyl group. Among the other instruments, the advantages of ATR FTIR is easy of sample holding, there is no need to grind or press the sample into pellets. In terms of speed, a complete analysis takes less than 5 minutes. It's a non-destructive method That is, samples can be recovered afterward. The surface sensitivity is excellent, especially for films, biomaterial coatings and corrosion products. Wide compatibility, that is suitable for solids, gels, liquids and powders. However, the limitations are only surface layers are analyzed, requires good sample contact with the ATR crystal. Rough or non-homogeneous samples may cause scattering or weak signals. ATR crystals, especially diamond, are expensive and fragile. Some samples like reflective metals may be unsuitable without coating. The applications of ATR FTIR, the biomaterials to conform protein, polymer or apatite presence on the implant surfaces. It is used in the field of polymers to identify degradation, that is oxidation and hydrolysis process, and curing process also. And it is also used in the field of corrosion, that is to detect oxides, hydroxides and corrosion inhibitors. It is also used in pharmaceuticals, like determination of compound identity and formulation integrity. Then the environmental sciences, analysis of soil contaminants, microplastics and water pollutants, etc. So this typical FTIR spectra obtained for titanium nanotube arrays at different water contents. How to handle the equipment? First, open the lid, clean the surface with acetone or IPA, then run a background scan with no sample on the crystal. Place the sample on the ATR crystal ensuring full contact. Then apply gentle pressure using pressure arm. Run a sample scan. The spectrum appears in real time. Apply baseline correction and identify peaks. Finally, save the data for interpretation and reporting.